All right, we've seen the first chemical properties, reaction with metals such as sodium, potassium, magnesium to form the corresponding, either you have methoxide, ethoxide, and all that. All right, also we see dehydration of ethanol with concentrated sulfuric acid. You know what sulfuric acid means? That's H2SO4. So, like I said in the previous slides, I said when you dehydrate something or you dehalogenate something or you dehydrogenate something, you are removing something. This will remove it. So dehydration means water. That means removal of water. So dehydration of ethanol with concentrated H2SO4 as the catalyst. So when we remove water from ethanol, we have ethene. So this is another Jamb question. Ethanol is dehydrated with in excess sulfuric acid to give ethene, C2H4. When you remove water there, you have C2H4, then plus H2O. So in excess, you have ether. Ether is formed. All right, ether is formed when when ethanol is in excess, ether is formed. Don't get it mixed up. When you dehydrate ethanol in excess H2SO4, you have ethene. Then when the ethanol is in excess now, not the H2SO4, when the ethanol is in excess and it is dehydrated, ether will be formed. Ether will be formed, or ethoxyethane. Ether will be formed, or ethoxyethane. The second one, reaction with acids, another Jamb question. Alkanols react with alkanoic acids in the presence of concentrated sulfuric acid as a catalyst to form alkanoates. Alkanoates. Very popular question in Jamb and Waec. Alkanols plus alkanoic acids will give you alkanoates and water. It's just similar to neutralization. Acids plus base. So the acid here is alkanoic acid. The base is alkanol. The salt is alkanoate and water. So you have an alkanol there. ROH. I told us R means any alkyl group. It can be methyl, butyl, propyl, ethyl. All right. Reacting with alkanoic acid, RCOOH. R can be any alkyl group. You're going to be having RCOOR. RCOOR, substitution reaction. RCOOR plus H2O. That ether there in that II reaction for esterification is not ether. It's a mistake. It's a typographical error. It's ester. 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 Esters are also called alkanoates. Ester. Look at examples. When you react ethanol plus ethanoic acid, you have methyl ethanoate. All you need to do, remove the H from the acid and replace and substitute it with the CH3 from the base, from the ethanol. You're going to be having CH3, COO, then CH3. It's a double substitution reaction plus water. So you have methyl ethanoate. When you react ethanol plus ethanoic acid, you have ethyl ethanoate and water. So esterification is the reaction between an organic acid called alkanoic acid and an organic base called alkanol to give an organic salt known as ester or alkanoate and water. The third one, oxidation of alkanols. Yes, primary alkanols are oxidized to give what I call alkanals, 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 or there is this name they call them, alkanals. Alkanals. Primary alcohols are oxidized to alkanals. Why secondary? Then the catalyst used there, is acidified potassium heptazodichromate 7, K2CR2O7, or acidified tetraoxomanganate 7. All right. So sorry, the name I was looking for is aldehydes. Aldehydes. So primary alkanols are oxidized to either alkanals. Another name for alkanals is aldehydes. Aldehydes. Aldehydes or alkanals have the functional group CHO at the end. CHO. So primary alkanols, the Jamb question also, primary alkanols are oxidized to alkanals. All right. Secondary alkanols are oxidized to ketones or alkanones. Alkanones. Secondary alkanols are oxidized to alkanones, while tertiary alkanols are not oxidized. So the way the Jamb question will come is this: they will give you a question: which of the following alkanols can not be oxidized? They'll put an example of a primary alkanol, secondary alkanol, and tertiary alkanol in the options. The answer is the tertiary alkanol. And I've told us how to identify tertiary alkanols. How do we identify tertiary alkanols? The only thing bonded to the carbon group are only the 3 alkyl groups bonded to the carbon groups. No hydrogen is bonded to the carbon groups. 3 alkyl groups are bonded to the carbon groups. You can see the example below.